talk about the AAS today, the Atomic Absorption Spectrometer. Before using an instrument, it's important to know the various parts. We'll start from left to right. There's two different gases that we have, the acetylene and air, which are going to control the temperature of the flame. So, just turn them on, lefty-loosey. So there's airflow going towards the AAS. Alright. In here is where your flame is going to be, which is the cell. And so it's important to have the hood on so any vapors can go up and not out. One feature of the AAS is that it looks at one element at a time by using the hollowed cathode lamps. There's two different styles that fit into the AAS instrument. This is an older style lamp, which you can just pull out. And it has an adapter, which that's how you know it's older style. It's important not to touch the end and get it all greasy or have different oils from your hands get onto it. This nickel lamp is a new style, and as you can tell, there's no adapter, and you can just slide it in. Under the case of the instrument is where a lot of the workings and pathways go. It's rare to open it up and see what's inside. In single beam instruments, there is an Ebert monochromator, and then in double beam instruments like this one, there's a Zerny-Turner monochromator. In here we have the nebulizer, which is going to scatter the atoms, which have been made into gas by the slotted burner head, which is where the flame will come out. The sample will come up through the capillary tube, which will sit in a beaker of the sample. 90% of the sample is not used, and it goes through this tube to the waste jug. And the waste jug is important because it has the one-way airflow, so there's no backflash and the jug and everything else explodes from the gas. For the waste jug, it's really important to make sure the tube doesn't have any kinks and you can get nice smooth airflow. It's also important that there's a loop in here that's completely filled with water, otherwise it will not work properly.
To turn an AAS instrument on, you just open this and press the power button. This is the AAS screen once the instrument has started. You can see here, this is the element for the lamp that is loaded and the wavelength that it will be scanned at. To install different lamps that scan for different elements, you can go to this, and then you can find the element here, and you can turn on and off the lamp there as well. Before you go into any further detail into the AAS, you want to set up the instrument, which helps to equalize with the lamp on and setting up the slit width in the wavelength in case these are changed at all for any of the lamps you have. To find the recommended conditions for your lamp, you just go to Tools, Recommended Conditions, and you can see the wavelength, the slit width, and your sensitivity for each of those. Next thing to go over on the AAS is the parameters for your scans. Clicking on parameters, you can see the integration time, the replicates, and the read delay. Here for integration time, this is the actual time for your scanning, so we can change it to 1 second. Replicates is how many times you will do the scan, so we can change it to 5. So we'll have 5 total scans in the end. And the read delay is delay between each scan, so we can change that to 1 second. Next, on how you analyze it, if you go to the tab Analyze, you can go through your analyzing of a blank, analyzing of a standard, or analyzing of an unknown sample. Next, let's turn on our flame. You must make sure that your interlock checklist is all set. We are only using air pressure and not N2O pressure, so we should be all set. And you just turn it on. As you can see, the flame color is mostly blue, but there's pockets of orange and other colors as well. This is due to junking up of the slotted burner here, which is causing the different colors to be burned in the flame. So now we can put in a sample. We have 1% nitric acid that we'll use in the capillary tube to be sucked into the AAS, and you can see the change in color of the flame. So now with a sample being in the capillary tube is when you would start your analyze. To turn off the flame, you hit the off button. And as you can see, there is no more flame. To finish turning off the instrument, you turn off the gases used, and you'll hit the button to bleed gases, and you must make sure that your vent's turned on so that any gases left over inside the instrument will be bled out and you won't have any explosions later on.